Hello, students. Today, this is your perspective notes. So make sure that you opened up your notes sheet in your astronomy notebook. Our learning target for the day, be able to give the location of an object in the sky by giving the direction, also known as azimuth, altitude, time and date, and a description of the object. Today's notes will include your fill-in-the-blank notes as well as a lot of vocabulary words that we'll be using throughout our astronomy course. So you will have to go back and forth between your notes document or your notes page and your vocabulary page. I'll let you know which is which. So first of all, take a look at this picture. What do you see? And do you think it's real? Because on first look, it looks like a headless gymnast. However, if you look at it from a different angle, it's not a headless gymnast. It's just somebody doing a leap, and her head is tilted back. Her perspective, or the perspective that we look at this picture, makes a big difference. How about this one? What's happening? And is it real? Again, if we change the perspective for a picture like that, makes a big difference with what we actually see. And finally, what are you seeing? And what's missing? The other person actually throwing the basketball, right? So again, for all of these pictures, the point is simply that the perspective that we're looking at makes a big difference for kind of how we understand things and how we talk about them. So first of all, these pictures were different because of perspective. So here's where your first bit of notes comes in. So perspective is what you see when you look at a situation. It's your point of view. It's what and how you see it. It's a certain way to look at something. It's how people look at things differently, or it's how we look at things from different points of view to come up with different explanations. So these are all kind of ways of telling you what perspective is, right? But it's all that different point of view, that ability to understand that not everything is the same to somebody else looking at something as it is to you, right? That's kind of perspective in general. So here is one of our first vocab words that we're going to write down, and perspective is the one that we're adding here. So you can see the definition there on the screen. That is a certain way of seeing something, influenced by location of observer, field of view, and what you've learned before, and various other things. This includes, or just a note that people have different perspectives, and we need many perspectives to explain. This might not sound like astronomy just yet, but I promise it is extremely important to the field of astronomy, and we'll get to why in just a moment. But again, the way that you see something depends on your location, field of view, and what you might know before, as well as other things. So make sure you get that vocab word down in your vocabulary page. And we'll go on. So, perspective on Earth. It shapes everything around you. That's where we're going to start off with our learning about our universe, our galaxy, our solar system, is we're going to start with the on-Earth perspective. So, back to our goal. We are trying to figure out how do we describe where a star is in the sky. And we're going to start off learning how to do that from our Earth perspective. So our perspective of the night sky have 4 main characteristics. They have direction, which is the azimuth. That's a vocab word we'll write down in a bit. The altitude, the time and date, and a description. Those are the 4 things we need to identify things in the night sky. Remember on your assignment that you are labeling that picture that is on the screen right now. In the little yellow boxes, you can just type the words that you see to correctly label your picture. So directions aren't as simple as you might think. So if someone tells you to head northwest for 10 miles, are you going the right way? Azimuth, another vocab word, so make sure we get that down in our vocabulary section. Azimuth is direction is described as an angular distance from the north point of the horizon, and it is called the azimuth. Angular distance, so it's measured in angles, and it's off of the north point of the horizon. So you find north, and then you go off of it, right along the horizon. It's kind of sideways from our personal perspective. That's azimuth. Another vocabulary here. So once we have the azimuth, right, the side-to-side perspective, how do we know how high up in the sky to look to find a star, right? Because the sky's real big. How do you know how high up to look? And this is called the altitude, or the height above the horizon measured angularly. So again, in angles. But it's the height above the horizon going up, okay? So here is where oftentimes we're going to do a little bit of guesstimating. So you can measure angles on the fly with your fist, and this is a tool that astronomers have used for a long time. The way to do this, there's actually a way to kind of figure this out, which I'll go over on the next slide. But your fist, right, the kind of distance here, across here, let's get a good perspective there. There we go. This distance across here is about 10 degrees. We're going to kind of try to have a way to figure out exactly what 10 degrees is. So my normal fist, includes your thumb in, right, is how most people have a fist. To get 10 degrees for my hand, I have to have my thumb out and kind of go this distance, right? That's 10 degrees for me. But here, let's figure out what your fist is. So calibrating your fist. Calibrating means to kind of compare it to a standard. So what you need to do is count how many fists you can fit between 0 degrees and 90 degrees. So 0 degrees is straight out at the horizon in front of you. You can't really do this inside. You do need to go out somewhere that you can see a horizon. The difference between the ground and the sky, right? And then you need to count your fists from 0 starting at the ground, and then you kind of can stack them on top of each other like this. And you want to keep doing that until you're all the way straight above your head. Okay? And then adjust your fist until it takes 9 fists to get to 90 degrees. So, right, I started like this when I first did it, measuring this way. I had to adjust and have my thumb out to make it so that there were 9 fists between 0 and 90 degrees. Right? That gives you 10 degrees. So that if you go out in the night sky, you can actually measure and say, well, it's about 45 degrees, right? Degrees up. And once you have that, your fist is 10 degrees, and you have something to get some measurements off of, right? Something kind of fast and easy. If you can't figure out how to do this, let me know and I'll try to help you. This is a great question to bring to our next Google Meet. But I would like for you to give it a shot and see if you can calibrate your fist and figure out kind of what you need to do to make it 10 degrees. All right. One other piece of information that we, of course, need is the time and the date, because our night sky looks really different between the summer and the winter. So stars move, right, during the night. You can kind of see them. It almost looks as if they're moving across our sky. And so you have to have a specific time. At the same time, because our Earth is a globe, and what we're seeing is a globe, half of the stars are above the horizon and half of them are below, right? Half of them we could see and half of them we can't. And so we actually have different constellations and different stars that we can see in the summertime versus the wintertime. So that's an important piece of information we need. So time and date and location. This piece, not making you guys write this down, it's not in your notes and it's not really a vocab word, but just be aware stars move. So you need to know where you are on the planet, what time it is, and what the date is, so that we can identify what that star that you're looking at might be. And different stars, again, are visible during different parts of the year. And different stars are seen in the northern hemisphere versus the southern hemisphere. So it's important to know all of those pieces of information. And with that, again, you don't need to write this one down, is a description. And this is kind of just what does the star look like to us. So it's color, right? Is it blue? Is it orange? Is it yellow? Is it white? How bright is it? We'll talk about how we measure and identify these things at a later date. Is it a fuzzy star, kind of has fuzzy outlines, or is it a really sharp pinpoint of light? And is it in a constellation, right? Identifying stars from the stars around them and kind of their position relative to the ones around them is a really common way that has been done for millennia to identify stars. So we're going to talk about sky charts and some vocab. So that picture there is a sky chart. So when we say a sky chart, it's a map of the sky, or the celestial bodies, the stars and planets that we can see in the sky for a specific location and time. Okay, they lay out specific location and time, and then all of the stars and planets and other things that you can see. Now, when you look at a star chart, you'll notice that west and east seem to be backwards. They're not on the side you would expect. I want you to take a moment. I'll give you the answer in a couple of slides, but try to figure out why would it be backwards. And again, sky chart here is a vocabulary word, so make sure you get that in your vocabulary page. So here are some pictures. There's a compass, right? North, south, west, east, like we'd expect. But when we look at one of these star charts, we're seeing north and south kind of like we'd expect, but then west and east are reversed from what we would expect from a compass. But now if you think about it, those directions, north, south, west, and east, like we're used to, are kind of for the ground that we're standing on. But when we have a sky chart, it's for directly above our heads, right? The things we're seeing above us. And so that kind of makes west and east get reversed, right? If we're moving towards the east in the sky, that's different than moving towards the east on the ground, if that makes sense. So kind of think about, it's the part of the globe and we're just kind of reversing which direction we're looking at, which is why east and west get switched. Here is another vocab word for us, celestial sphere. So I've mentioned this one before. I talked about it in our last Google class a little bit. But again, let's get that definition down in our vocabulary page. So it is this huge imaginary sphere on which all the objects in the sky seem to rest, right? From our perspective, laying in the grass staring up at the stars, it kind of looks like this big flat black bluish canvas with all these bits of light on it. And that's what we call the celestial sphere. Now that we've learned more and we've been able to send things out into space, we know that's not true. That's not how it actually is. But that's how the earliest astronomers started talking about the stars, and that's how we're going to start talking about the stars. Another vocab word is the horizon. So this is where the Earth and the sky appear to meet in the far distance. So when you're outside, you can see way far away, kind of where it looks like the ground is touching the sky. That's our horizon. It forms a circle on our celestial sphere, as you can see in the little picture on the right. Zenith, another vocab word. This is the point on the celestial sphere directly above the head of the observer. Okay, so if we're looking at this diagram of the celestial sphere, person's in the middle and the zenith is directly above their head. Right? That just kind of gives you an orientation for where you're looking at, right? And the transit or solar noon, this is the point when the sun has reached its highest altitude. We oftentimes think about this as noon, like our time, 12 o'clock. But the reality is most days of the year, it's not exactly 12, right? For the time. But it's the position in the sky is the transit. That's the point that the sun has reached its highest altitude for that particular day and location. Another vocab word. And I believe this is our last vocabulary word, the meridian. This is a word you're probably familiar with and have heard in your geography classes. But this is the perpendicular circle through north, zenith, and south. Okay, the perpendicular circle through north, zenith, and south. There's a famous meridian that I'm sure you've heard of, the prime meridian, and that runs through the 0 longitude on our globe, splits up the eastern and western hemispheres. It's not really based on anything, it's just a point that people picked as they were making maps. Right? So we use the same kind of thing, but in terms of the sky. We talk about the meridian. All right, and that was it for our notes and our vocabulary for today. These will all come in handy down the road throughout the rest of our astronomy course. Feel free to pause, review the video as you need to make sure that you've got some good definitions, and then fill out those other columns on your vocabulary form. With that, have a great day, and we'll see you in our next class.